Okay, this is the second video of 12D, the odd numbers. Okay, so we stopped at question 3.2. Okay, at 3.2, we were asked to express TAS in terms of x. So TAS, we said TAS is going to be 3x. Okay, so the question then say in 3.3, if x is equal to 30, determine the values of the angles of triangle POA. POA. So this is a triangle here. So the angles of this triangle, firstly, is that angle P, which is SPO, is equal to x, which is equal to 30 degrees. Okay, that is the given. Then PAO is equal to 3x. Why? Because the vertically opposite angles are equal. Okay, so it's going to be, the reason there is vertically opposite angles. So 3 times 30 is going to be 90 degrees. Okay. And then O1, of course, is angles in a triangle. So there's 30, there's 90, and then O1 is going to be sum of triangles of a triangle. So it's going to be 180 minus 90 minus 30, which is 60 degrees. Sum of triangles, and it's triangle POA. Okay. Let's look at number 4 for 3.4. In question 3.4, it says prove that POST is a rhombus. POST is a rhombus. For this to be a rhombus, there are 6 properties to prove it's a rhombus. Okay. The one I'm going to use here is that the diagonals bisect the vertex angles. Okay. There's 2 of those shapes. It's either a rhombus or a square, where that is the case. And in a kite, it is one diagonal bisects the vertex angles. There's only one of those sets. Here, if I prove that 2, the least it can be is a rhombus. So here we can say that that angle is already equal to that angle. Okay? So, do we need to now first prove? Okay, these lines are already parallel. So it is a quadrilateral. So at this point, it's already a trapezium. Okay, the least it can be is a trapezium. So this is 30, so there's diagonals bisecting the vertex angle there. S1 is the same as this here, which is also x, which is 30. As you can see, but why is that 30? Because we haven't proven that those lines are parallel yet. Okay, I'm just looking at the easiest way out to prove that it's a rhombus. Otherwise, that length is equal to that. And this is equal to that. Okay, we're rather going to go with the lengths. It's going to be easier. Otherwise, we have to go with the fact to prove that it's first a parallelogram and all of those things. Okay, so if we prove that all the sides are equal, the adjacent sides are equal, and then, but then you could have been a kite as well. Okay, so it's those lengths equal as well. Okay, so a rhombus, right? And the vertex angle is being bisected. Okay, so it's a long process, but let me just check if there's an easier way. Okay, so what I will be doing is what I'm seeing here is that I can prove that that length is equal to that. That's not the issue. This here is equal to that there, not the issue. But how are we going to link these two? Can you see that? So that is 2x. It's x, so that's also 2x. Okay. Because of sum of triangles. Okay, I'll go with that, yes. Right, so firstly we know that PO is equal to OS. Why? The fact that it's a radius. Okay. Then we know that since uh, TPA is equal to angle S1, which is equal to X. Okay? Did I say why S1 is X prior to this? No. This is going to be X, S1 is going to be X because sum of triangles. Okay? Okay, I'm missing this up here. Let me just check what I've got and what I haven't. Yes, I haven't mentioned that before. So this is going to be angle at center is twice angle at circumference. Sorry about this diagram, it's now messed up, okay? But you see as angle at center, we got 2x there already. Angle at center is twice angle at circumference, okay? So there's an x. Then I'm going to come with that also being 2x, okay? Because of, we need to prove that the vertex angles is being bisected by the diagonal way. Okay, so which is equal to x here, as we said. So therefore PT is equal to TS. Why? Because it's sides opposite equal angles. Okay, sides opposite equal angles there. So now we have two adjacent pairs of sides are equal. Two pairs of adjacent sides equal. But the least it can be is a kite as well. So to prove it's a rhombus, I can't just prove that. If you look actually at this shape here, that this diagonal is actually bisecting the vertex angle. Okay, where those are now equal. So yes, that could be a rhombus at that point already. So now we say since angle OPA is equal to TPA, which is equal to 30 degrees or x. Okay? Therefore, POST is a rhombus. Why? All adjacent sides equal. The adjacent sides are equal. And your diagonal bisect the vertex angle. Okay, so therefore it's a rhombus. Why? Because you got your adjacent sides being equal and your diagonal bisects the vertex angle. You see, if I had gone this way around, then the least it can be is a kite, because these two pairs of adjacent sides are equal and the diagonal is bisecting its vertex angle. However, this way around, it will never be a kite, because here you got your adjacent sides are equal, this pairs of adjacent sides are equal. Okay, and it's bisecting the vertex angle. Okay. I'm sure there's an easier way. Now I'm just going to check at which approach the textbook use. So this is 12D. It might be even an easier method than what I used. As I explained to you many times before, right? This is just what I see at the point of doing it. Alright? There might be easier ways of explaining something. But as I explained to you, this is what it is. Let's just check number 3. In number 3, we are told that, okay, so they got O1 and S01 and is double S1. So they use that thing. Then S1 is 30 degrees, so we just named it X. Then they're saying that these lines are parallel, alternate angles. So now this is now a parallelogram to them. Okay. Okay, so they first proved this is a parallelogram. Then they proved that the adjacent sides was equal. And then because of the adjacent sides equal, it has to be a rhombus. So they say it's a parallelogram or one pair of adjacent sides equal. Okay, as I said, it might be an easier method to have followed. Okay. Okay, now this is now number 5. In number 5, we are told that BOE, OE is the diameter. If this is the diameter, of course, then this angle here is going to be 90 degrees. Angle in semicircle. O is the center of the circle. Center of the circle AD is perpendicular to BE. Okay, so that means that's 90, which makes this length equal to. So AF is equal to FD. Why? Perpendicular from center to chord. Then we are told that B2 is X. Okay, we must prove that. Right, we'll start proving this in the next video.